follow-up video to the speed of sound videos and my argument that sound waves are propagated through atmospheres of all various kinds through a mechanism of acceleration, that there has to be a minimum acceleration, that is, in my opinion, the speed of sound, that has to be achieved to create the wave function, to create the propagation mechanism that makes a thing called a sound wave, something that will actually move through the atmosphere and not break down into chaos and disorientation, that it will have a strength to it will be maintained, unlike mechanisms such as heat, which just kind of float about. You know, certainly aren't as directed and don't move nearly as quickly. So first off, I guess I'll do deterministic one guy. The maximum velocity. So velocity and acceleration, there we're in tricky territory, right? This technically, I'm talking about the acceleration of a wave. Okay, it's acceleration that creates a sonic boom. It creates the faster than sound movement that creates the wave, that initiates gets into. Okay, so again, we're back to this argument, like if you had magnets and you push them together slowly, you can just bounce them off of each other. If you push them quickly, you can bang them into each other. The velocity of a loudspeaker cone is Vp equals 2 times pi FL, so you got frequency in there, XP. So I don't know what all this crap means beyond velocity and pi and whatever, but I'm just saying this doesn't really mean anything to me. Sorry. You know, as again, it's not, number one, the A isn't in here anywhere, acceleration isn't in here anywhere, so without that symbol, it's not going to say anything to me. I'm not talking about how fast a wave propagates. You know, anyway, in order to get a cone up to speed of sound at 50 hertz, well, again, you're saying that frequency has something to do with the speed, and I'm saying frequency has nothing to do with acceleration, essentially. Not much to do with it anyway. The cone would need to be displaced approximately 1 meter, okay? Well, I'm just saying that's by your formula, which I don't think is going to tell me initiation speeds. I think it is safe to say there is no speaker that is anywhere near that much displacement. Well, it's safe to say that, but again, you're assuming that my argument is that the entire wave function is created at that speed or something like that, and that's not the argument. Therefore, unless you can show that the equation above is not accurate, well, I'll attempt to do that. I think it is safe to say that matter does need to be going faster. Safe to say that matter does need to be going faster than the speed of sound to create sound. Yeah, well, you're just making my argument. I think it is safe to say that matter does, I think it means not, need to be going faster than the speed of sound to create sound. A medium must be accelerated in order to create sound. I don't understand your point. Yeah, I thought I read that before, and I thought you were saying, yeah, I put the not in for you, but it's not there. Anyway, okay. So what else is news? So Hoffa today did bring up the crack of the whip, said yes. So I'll go to his video, which is actually a pretty good video, but the comments he's retracting what he said, which was kind of weird. But it doesn't matter. I mean, it's all gotten a bit convoluted. Well, it gets very complicated because, like I said, I think it is a subtle mechanism change. You know, there's a difference, and the difference is speed. Yeah, well, you know, obviously. So anyway, so a simple drawing. Alright, so let's say you're creating a wave. I call that like whatever, whip speed or something. How fast you have to move your hand would probably parallel this function. But here, let's just say this is, you know, your regular typical sine wave. You know, what you're really talking about here, what I'm talking about, is the fact that, as you can see, when this wave propagates through time and space, it's, you know, if you did it proportionally, you can quite obviously see that this distance from, you know, this point, well, I don't know how to do that without screwing up the drawing, but anyway, from this point to this point is obviously much longer, okay, than say this point to this point. So there's much more distance traveled in the same period of time by the wave function going from this initiation state, so that there does need to be a whip speed, an acceleration going into the creation of the wave, then a deceleration, and perhaps an acceleration in the reverse direction, but usually the tension of the substance will take care of the rebound section of the wave function, which I'm not, like I said, I don't want to go too much into that, but you know, that's another detail of this thing. And again, we've sort of agreed, at least people have, that waveforms, and especially sound waveforms, are often shaped quite differently. You know, they'll have a sharp peak and, you know, come down to something like this. You know, so it'd be a much different waveform, have other frequencies built into it. Certainly with instruments like a guitar or something where the strings vibrate the wood, and it's the wood that produces the sound. You know, these are, you know, it's complex deciding what part of the instrument is creating the substance of the sound, and through what kind of mechanism. And certainly, again, I'm just going to argue, though, that right here you see you have an obvious difference in distance and time. So you can't just sit there and take the average of these things and say, okay, I'll average these and call it velocity. Okay, now what you have to do is you have to account for even subdivisions. I mean, I've used large divisions here, but technically if you subdivide this even closely, even more specifically with finer lines, you'll get even broader, you know, 10 times, maybe 100 times changes in speed of generation. So when you give me a frequency number, you've got to multiply that frequency number by some factor of the average to get to the initiation speed, the speed of the initiation of the wave, the acceleration required to initiate a wave, because it is essentially a force against a kind of gravity. It is a much the same as escaping gravity or escaping some force, where, you know, initial acceleration is high, and once you gain some momentum, you can just gain more speed much more easily over time with less force entered. But you know, obviously the initial point, well, I guess gravity would be a bad example because you move quite slowly until you gain velocity. But obviously in this function you have no friction, theoretically, to perpetuation, so this distance is significant. Well, anyway, I mean, it's just, you can just see it quite obviously. There's a greater distance of there's more wave created in a shorter distance in this pattern, and that indicates more acceleration. And so I think that is maybe the cause of the dispute here, that velocity and acceleration aren't the same thing. And I'm certainly talking about acceleration at the speed of sound at some point in the wave, not you know, in excess of the speed of sound, that initiates, it creates the propagation of the wave by breaking through the electrostatic, or however you want to describe them, tensions that would exist inside the, again, we're back to the atoms, but what I'm basically saying is the atoms have a structure, and that you have to collide. Let's just say if two atoms were going to bang into each other, they have to collide with a certain amount of acceleration, a certain speed, to be able to have a contact that is on this inner surface. So to break the boundaries of this resistance, of these outer rings, let's say, and they need to contact each other on these inner forces. and it's these inner forces that propagate the wave. So they have to, if they move too slowly, then these outer forces will just bounce them off in, directions of, however imbalanced their contact is. Whereas if they come in contact and hit this way, it's more like, when you have those kinetic balls on a string and they hit each other and the forces passed right through them. More like that. So that's my counter argument to that point. So we'll go to Hofladay's video. So what's a comment there? Yeah, this Dinah Cat Loves Me guy, I don't like him much. If you speed up the system, then he's probably brainwashed the poor cat, because I don't think a cat could love this guy. But anyway, if you speed up the system to the point where the waves are generated too quickly for the waves to travel at a significant distance, the equation becomes chaotic at some point. I studied this 20 years or more ago. I don't have it in my head anymore, but I do remember creating chaotic systems that way. Yeah, well, I guess the argument is if something going in too fast. Well, I don't know if you can move one of these kinetic balls too fast. I suppose you have enough force where you just knock them all in some kind of, you break down even further into the core of the substance. So maybe there's a third energy field, and you break into the third energy field, which creates some other too much heat or too much something else. But anyway, hopefully, yes, I think sound pressure waves must then be created at a speed less than the speed of sound, but there will be a minimum speed at which wave equation functions propagation will not take place. You cannot simply say, oh, if you raise your arm or clap your hands really slowly, the wavelength is infinite or really large. At some point, the physical characteristics will no longer mean the wave will be propagated as deemed by the wave equation. Now I recall it is because going faster than the speed of sound that we get a fundamental change in dynamics. Well, that's what I'm talking about. Is that you have to have that fundamental change in dynamics to create to propagate sound, which produces the sonic boom. Yes, and these sonic booms, we are familiar with them as large objects moving faster than the speed of sound, and people just don't recognize that when small objects move at the speed of sound, they also create sonic booms. They're just not as loud because they're small things. And when they're very, very small things, those sonic booms can be used as an instrument, creating multiple frequencies and different wavelengths, varying wavelengths, of course. Anyway, so I don't think I have to go any further than that. Some Quinta guy added some kind of scum comment. And Mendham also said that the sun determines which way the magnetic poles of all of the planets in our solar system face. Yet he has no knowledge of the molten iron cores of certain planets. Well, there's all kinds of theories about what's at the core. Lots of aluminum. Anyway, but yeah, it's really quite irrelevant to my point, which is orientation is created because the sun has a very lengthy influence. There's just such assholes on the internet. Impero made a comment, but totally irrelevant to the subject. So typical Impero bullshit. All right. Yeah, so the Dana Cat guy says, at 7:28 you are getting confused. If he raises his hand slowly, the wave he creates moves at the same speed as if he moves his hand fast. That's where you're wrong. I mean, the wave moves at the same speed, but you will not be able to create the wave if he does not whip. It's like even the pressure waves. When you use the spring, the compression waves, you do have to kind of pop the wave into the instrument. You move it too slowly, there won't be any propagation of a wave. So anyway, yeah, that's enough. I'll just stick with this part for now. This looks pretty convincing to me. acceleration is the argument. And so I'm claiming there's an acceleration somewhere in the creation of the wave that is in excess of the speed of sound. Okay, not a velocity, an acceleration. The same thing as a velocity, but I just mean you have to do velocity, not average the velocity. You have to account for all the velocities within the creation of the wave. All the velocities count, not just the velocity as an average.